All right. Lane, are we good on the live peer?
We're good.
All right, awesome. Thanks everybody for joining. Let's go ahead. We got a lot on the agenda today, so let's jump into that. Um, Dimitri, I think you're on here. Let's start with testing, and you also had an EIP for a common Genesis format across all client implementations, or Genesis.json. So basically, something that everyone can agree on.
Yeah, that's right. I was thinking about this for a long time. Now, when I started doing this RPC testing tool, I see that each individual client has its own Genesis config field and field names and parameters, but some of them are basically means the same, and we should come to agreement. How should we name it? At least the format should be general for all of the clients. That would be much easier for everybody.
Thank
Yeah,
you,
if I can, I totally agree about that. But actually, I think there are two problems. One of is the structure of the Genesis file, which differs between the clients, and another is the kind of semantic meaning, where some clients have like fork block number for each for homestead, a fork block number for this and that, whereas parity, for example, has number. They haven't divided it up by forks necessarily, but by features. And that may vary between clients, so that they have feature X at block X instead of certain hard fork. So
Yeah,
that's
maybe we could come to a standard in this question.
Yeah, I think we could. And so from parity side, this is actually a discussion we had recently because we're moving around some parameters to make it easier or possible to have POA chains that don't configure these sort of Ethereum specific EIPs and hard forks. And a part of the problem here is also when you change the spec file, like how do you migrate from one to the other? So probably useful to have like a migration framework discussion here as well, like what happens when it changes, and if there's breaking changes, how do we deal with that?
Yeah, I think it would be great if we could put together some group to work on this, because every time something changes, I notice it when Hive goes down or EVM Lab stops functioning, and I'd really like to get some buy-in from Parity and Geth and testing.
Yeah,
And CPD.
that's why I introduced a field called the version in that Genesis proposal. We could implement a scheme for the format and call it version 1, and then at least we agree on this scheme and everybody implemented it, and it should work.
So, Martin, since you have rights in Gitter to make new channels, could you maybe make one, just a quick channel to throw some people from different clients in to discuss this? I can figure out the other stakeholders if you'd like.
Absolutely.
Great. Dimitri, does that sound good to have a Gitter chat and start kind of fleshing this out more?
Yeah, at least something.
Okay, great. And otherwise, guys, comment on the EIP. It's linked in the agenda for any other feedback. Okay.
I mean, Genesis is basically a description of the first block and the state and some optional parameters. So just trying to figure out what are needed and how should we name it.
Okay, sounds good. Let's move on to the next topic, client updates, and then research updates after that. I decided to move them from the end of the meeting to the beginning, so we're not having to rush at the very end of the meeting through this. And we can just, if we run out of time, we can just table some of the other items till afterwards. That's a series of changes that are going to be happening to this meeting. So if we go to client updates, we can start with parity. Frederick?
All right, yeah. I'd say the biggest update is the 1.11.1 release, we have a bunch of performance improvements and general improvements here, but the two main ones are we've introduced CLI for Whisper, and we've have a complete refactoring of the transaction queue. So verification is happening in parallel. Previously, fetching items from the queue was order 1, but now and inserting was order n squared. Now it's much more performant for inserting, and we've kind of split out the transaction pool to have like a scoring and readiness thing separately, which makes it a lot easier for miners to like view the pool in a more coherent way and be able to do a lot more with it. So I think that's a pretty big change on our end, but otherwise it's just general improvement.
Okay, thanks. Geth, I guess Peter.
Hey all. So not much. We're mostly working on performance improvements. We've seen that in the last couple of weeks. Transactions on mainnet, especially spam transactions, kind of went up. So we're trying to track down some issues that we're seeing, especially around memory usage. And I'm not really sure. We have a few hunches. Hopefully those will be fixed. I mean, hopefully those will fix the issue, but we're currently benchmarking them and testing. Apart from that, we just had a meetup in Stockholm, a small team meetup, and we tried to figure out which direction to take Go Ethereum to. And one of the directions that we would like to work towards is basically some form of accounting, resource accounting for the light client, which should be able to help a lot with incentivizing running full nodes. So basically, we would like to create some form of basically separate the light client, the resource counting, which client uses how much resources, and probably the monetary layer, so that anyone can basically monetize their node however they like with whatever mechanism, and then Geth would just count it and make sure that you adhere to your own quotas. And yeah, I think that's mostly it. I've done quite a bit of hacking on a new synchronization, but I don't really have any numbers yet. But I'm hoping that by next by next core dev meeting in 2 weeks, I could give you guys some hard numbers on whether it's worth it or not. If it seems to be worth it, I'll probably post some document next week so that everybody will have time to look through it. That's it.
Cool, thank you. CPP Ethereum, Paul.
Hi. From our side, important news are I've sent binaries for CPP Ethereum. It includes if client and test if tool to GitHub releases. It's now in form of development snapshot, but we'll make a stable release soon. And we have some RPC improvements and fixes. And also all the tools within CPP Ethereum accepts dynamic loaded EVMC implementations. And you can load, for example, EWASM backend as a shared library, so you don't have to rebuild all the source code in chain in case you would like to use some external VM. Yeah, that's all I have from the interface point of view.
Okay, thank you very much. Harmony, Dimitri.
We have finished everything we want in this release. It is release candidate now, and we started to testing it. It's mainly a performance release. We have improved processing time up to 5-10 times. Before, it was difficult for us sometimes to stay on the top of the chain. Some blocks arrived earlier than we processed previous. So we have solved this issue. Now it's fast. We are still behind Get, but it's a big improvement for us. Also, we have fixed a lot of issues with stolen of synchronization, with memory usage, and we are going to test this and release in 1-2 weeks. That's all, I think.
Okay, thank you. Anyone from Pegasus? Okay. Anyone from Trinity?
Yep, this is Piper. It sounds like us and Harmony are on a race for who can get their main release out. We're in roughly the same boat. We've been knocking out low-hanging performance issues for the last like 2 or 3 weeks, and have gotten things down to a point where we at least probably have a viable alpha right around the corner. We have mainnet, full and fast sync functional, same with functional light client, working on getting some of the RPC endpoints up and running against those, and basically knocking off a pretty short checklist right now towards public alpha.
Okay, great. I'd like to introduce Jeff. He's with the Ethereum team. It's a new client written in Elixir. Jeff, if you wanted to kind of just do a quick intro of the project and updates.
Hey guys, thanks for having me here. Yeah, we started Ethereum about, it's a pretty new client, probably about 6 months ago. And the focus has been to help, diversify the community. Plus, a lot of people have been using Elixir for their backend servers. And we figured having a lot of these libraries in place would be beneficial for people building services on top of Ethereum. For us, there's just been a lot of work on getting to a V1 client. So a lot of the libraries we've been focusing on are for interacting with backend services. Plus, you might have heard of the work that POA Network is doing. They have a Mana fork, a fork called Mana, and the goal of that project is to push to having a full synced first-class client. So just glad to be here and help out any way I can.
Awesome, thanks, Jeff. Is anyone from Nimbus here? Okay. Am I missing any clients? Not research teams, but clients. TurboGeth put their update in the notes and the agenda if anyone's interested in that. There's some really cool improvements, and there's also a link to the video Alexi did at EdCon, which was really good. I was able to catch that. Okay, for research, let's start with Casper. Danny, I think you can take that.
Yeah, hey. We've been honing in on the EIP spec as we've been talking with clients and kind of figuring out all the little details. The updated spec is live and associated changelog in the discussions to issue. There's some concerns about the parallelization of vote transactions and how clients will actually handle this. And initially, these conversations are leading us to think that we might put all of the data that votes do modify in a separate contract that's guaranteed to not be modified by anything else but those votes. So it'd be really easy for clients to just copy the state root hash that contract around. But anyway, we're working on that. We're also working on some decentralized pool implementations, just kind of some proof of concept stuff right now. This is also something that recently made it onto the grant wish list if anyone out there listening is interested in getting involved. Other than that, just keeping chugging along. I know that a lot of the clients are implementing. It's very exciting getting there.
Great to hear. And then, let's see, Drops of Diamond, James?
Yeah. So I just wanted to mention, our project. So yeah, we just been working on blob serialization, so that's been finished. I'm just looking into developing a P2P network with libp2p or Rust libp2p. So yeah, that's all I have to say.
Okay. EWASM, Any number of people can take that, Lane or Casey. Lane,
Casey, do you want it?
Yeah, sure. Or
go ahead, Casey.
Great.
Yeah, our focus for eWASM has been on EVM2 WASM, and that transpiles EVM bytecode to WASM bytecode, and it would allow for a client that only has a WASM VM to be able to run on the mainnet and execute EVM contracts. But the main reason we've been focused on that and testing it on CPP Ethereum and is to get greater WASM, greater test coverage over the eWASM interface, the EEI, because with EVM2 WASM we can transpile all the EVM state tests, the multi-client test suite, and check a lot of edge cases and discover. So we're discovering and fixing bugs in Hera and in EVM2 WASM.
Okay, thank you. Phil, is that Phil Dyan or a different Phil? Hello, Phil. Are you able to hear us? I'm not sure if Phil has a mic or anything, but if you are able to talk to us later, Phil, just jump on. I wanted to see if there were any updates from your end on the Jello paper or anything else like that. So now that we've gone through all of the updates, the next item on the agenda is reward clients for sustainable network. When each transaction is validated, give a reward to clients for developing the client. And I think there's an Ethereum Magicians thread that's linked in the agenda, as well as the EIP itself. And that's James. James, if you want to just kind of briefly explain that and ask for feedback.
Okay, so the EIP is pretty long, but the specification itself is pretty short. So it's just saying that you would have an arbitrary byte array addition added to each block, which is just the previous block verifications, and in a transaction you could add a block hash of the previous block verifications with access with the address of the client has verified the transaction. And in order to make sure that the client is legitimate, they could be included in an access list, and you could check that the address is provided is in the access list in order to check that it's legitimate. So that's essentially it. However, there are complications with implementing the access list in order to do it in a trustless way. So there's a number of proposals to do that. However, they all have difficulties with them. So, I mean, they could be done, but they might not be ideal. So, yeah. I also initially had a proposal included to reward full nodes, but I decided to remove that because Casper is going to be incentivizing validation, Casper FFG. So when that comes through, we won't really need to incentivize full nodes for verification. However, there still won't be any incentives for relaying with bandwidth or downloading, as well as storing state and data. So that would still need to be incentivized, and proposals have been made elsewhere on that, which is detailed in the EIP. So yeah, if anyone has any questions, yeah, feel free to ask. But yeah, there's more details in the EIP.
Yeah, does anyone have any questions or comments right now, or?
Yes.
Yeah, I have one question. So I haven't dug into this, so maybe what I'm going to ask is really stupid, so apologies for that.
That's all right.
But if you are including any metadata in the blocks which aren't part of consensus, aren't verified, then let's suppose that parity, we have a block which has a metadata that, for example, parity verified it, or whichever parity nodes verified it. And then I'm going to be an asshole and release a new version of Geth, which simply strips these out before forwarding it to the network. Now, of course, what happens in this case?
So yeah, I'm not sure if this will answer, but let me know if it doesn't. But it says when a client verifies that a previous block is valid, and that's according to the validity definition in the yellow paper, then so that yellow paper is a specification for all common clients. So that will determine whether a block is valid according to consensus rules. So if Geth released a new release that had some, it would need to make sure it complies with common.
Yeah, of course.
rules.
So what I'm just
So
saying,
then it would, yeah.
So what I'm saying is that if you are tracking the accounting of which client verified which blocks, then all other clients in the network, so there's no incentive for other clients to actually forward this metadata, this accounting info. So everyone else can just strip out this info and forward the blocks themselves only.
Sure. Yeah. So I mean, obviously, you want multiple clients, not just one client, to be verifying a block. And I believe, guess the previous block verifications is an arbitrary array. Any client could include that they have verified it. So it's any node is verifying it, and it would insert the address of the client of that node that has verified it.
I think maybe I can ask this question in a different way. The question is, if I'm a Trinity node and I'm the first person that a newly mined block from a Go Ethereum node was broadcast to, can I strip out their verification info and then forward the block on to other people, and will that still be a valid block?
No, I wouldn't say so, because you're just inserting that you have verified the block to that a previous block. So it's just like putting the block hash to say that you verified it, and this is in a future block. To say that
are part of the block hash, or the.
So when you verify a block, you're inserting that you have verified in a future block. You would insert the block hash of the block that you have verified.
Well, okay, but then that basically depends on miners' goodwill to insert these stuff into the blocks. So let's suppose that if Trinity verifies all the blocks, then why should a Go Ethereum miner even mention that Trinity verified it?
Yeah, I'm not sure.
I'm deliberately trying to break it here now.
Yeah, I understand.
Maybe we can continue.
Yeah, I'll have to think about that.
In the magician's thread.
Yeah, I have another comment. So Peter mentioned earlier that there will be an incentivization to run full nodes once you can monetize on less clients. But that's not neither here nor there. Regarding the EAP itself, I still think it's a little thin on actual technical data, but it's mostly a lot of discussion and about the thing, and it's very briefly about the actual technical implication, what is hashed and who does what kind of. So I still think it's a bit too early to actually discuss this with EAP in a Cordev call.
Okay.
Just to add a minor addition to it. So currently, for example, we have two. We want to incentivize running full nodes. We have basically two problems. One of them are light clients, which are obviously leeching the network. Those Jolt is working on a few monetization schemes. I won't go into that. And the other is basically just running a full node without serving light clients. That's also still expensive because you are wasting your bandwidth to help the network. And for example, it's really, really hard to solve this problem because it's really hard to fake that you verified a block or that you indeed uploaded 1 gigabyte of traffic to whoever wanted to join the network. But maybe Swarm is actually the direction where we want to take this. So if the reason of being of Swarm would be to share data and to be able to run a tit-for-tat protocol, essentially as long as you upload approximately the same amount of data as you download, you don't care. And if you download a lot more, then you need to somehow make amends. So what I was saying is that maybe that would be actually a nice approach to solve this problem altogether without having to come up with without having to reinvent Swarm on the top of Ethereum protocol.
Right. Yeah. You could also have TrueBit to use interactive verification as well, but that's more suitable for blocks transactions that exceed gas limit. Yeah.
Okay, great. So it sounds like we'll flesh this out more in the Ethereum Magicians thread and try to get some more technical details in there to kind of spruce it up a little bit. But yeah, thanks for bringing this topic, James. And is that pretty much, is that good for now?
Yeah. That's fine. Yep.
Okay, perfect. So next, we have EIP 1057, ProgPow, a programmatic proof of work. It's written by RadixPy and then ifdef-else. Ifdef-else are 3 people who are working on it, and they've actually joined us in the call. So if you 3 want to, just at least one of you, mainly talk about what this is, a little bit about how it works. And the goal of this topic is not to decide exactly like if this is going in or not, but this is a really good way to kind of either replace the current proof of work scheme or have as a backup if we ever need to replace the current proof of work scheme. So at the very end of the topic, I'm going to kind of just query the core devs and see if anyone has changed their mind with regard to having a strong opinion on implementing this now or waiting till Casper gets implemented and not changing the proof of work algorithm. So to start, if y'all could just introduce what this is and what you guys are doing.
Sure. Can you guys hear me okay, first and foremost?
Yes, we can.
Okay. So no pressure. So proof of work is a new proof of work algorithm that's designed to close the efficiency gap available to specialized ASICs. So in the current implementation of Ethereum, an ASIC can get a potential for 2 times speed up. And this is because a large portion of the actual programmable hardware, in this case a GPU card, is not used. So what prog proof of work does is it starts utilizing more of the GPU card. It utilizes specifically, it engages more of the core. And in doing so, it means that specialized hardware is not able to gain its large efficiency speed up. So we have taken great lengths to ensure that implementation of this is as easy as possible. We've already got the minor implementation up and running on our GitHub. It's public and ready for review. We've also started with the first client. Yes, Alex, someone should link it to you. We've already started with the C++ client. It's already committed as well. And our goal is to ensure that all of the clients for Ethereum are already done with prog proof of work implemented, so that the Ethereum developers do not have to spend any development time or effort on the implementation, just the testing. I want to introduce Def and Else. These 2 are hardware engineers that have been working with mining projects in the past. Specifically, Else, I'd like you to go through a brief technical description of prog proof of work and how it works for the end user and how we've closed that efficiency gap. So if you could talk about 5 tunable parameters.
Yeah, so basically the current ETH hash isn't so much a proof of work as it's a proof of DRAM bandwidth, that all the algorithm really requires is a large amount of DRAM to store the DAG in, and then high bandwidth access to that DAG. So a specialized ASIC can be made for that by basically removing the majority of the ASIC and only having the frame buffer interface. The algorithm that we developed takes the ETH hash as the base, but then adds, using the register file, high throughput math and caches, so that any ASIC that implements this also needs to implement those. And once you've implemented all of those, you've basically implemented a full GPU. So any implementation is going to be almost to the level of a GPU.
Okay, so my main queries right now at the developers meeting would be, what barriers do you see for adoption of proof of work? And I will tell you what has been referenced to me on my side. The major arguments have been that we're not seeing enough adoption by both stakeholders and developers. And this, I believe, is an educational issue that we are working on. So we need to educate the public more on why this is so important for the gentle transition of Casper, FFG, into the hybrid model. And also the other statement we've been given is that it would basically add too much work for the developers, which we're doing our best to help out with by making sure all the implementation is already done.
So yeah, does anybody have any comments on basically what was just presented? Any questions?
Yes, I have a question with regard to, well, actually, two issues that you may or may not have thought about. So one of them is that, for example, as far as I know, ET hash on CPP Ethereum only is an only little endian implementation, and we actually had to re-implement the whole thing in Go to be able to run ET hash on top of big endian systems like MIPS and whatnot. This may or may not affect you, probably not, just saying that it's probably something you need to take care of or take care with. The other interesting issue is that I'm not sure how your algorithm will scale to mobile use, because currently, currently ETH, if you want to mine a DAG, if you want to mine a block, I mean, you generate 1 gigabyte plus or 2 gigabyte, right? I don't know the exact number, how large DAG, but in order to verify it, you can do that only using a 40 megabyte verification cache. Now, the issue is that this verification cache is insanely expensive already on mobile phones. So it takes a fairly modern mobile phone a few minutes to generate it. And the question is that if you introduce a new proof of work mechanism that on top of the memory thing also adds CPU overhead, then how does that impact verification performance, especially on low-power devices?
Sure. So let me just address your first question. We are working on the Go implementation next. We're hoping that this should be rolled out this week. So again, we are taking on the implementation work ourselves and ensuring that there's nothing the developers of the Ethereum community need to do. I will turn to Def on how it, Mr. Else, on how it scales through mobiles. So Mr. Else, take it from here.
So for the verification side, calculating from the cache the DAG entries that need to be used, that's extremely expensive. It's a couple thousand instructions. So adding to every loop, we're only adding about 30 instructions, the randomized instructions. That's going to basically be in the noise compared to generating the DAG data that you need. Right now, the parameters end up generating twice as much DAG data. We could tune that so that the same amount of DAG data needs to be generated. So the verification times will be approximately the same.
Mm-hmm. Sure thing. So I'm more or less brought this up so that you are aware that ETH is already problematic on mobile. So it's just a thing. Let's try not to make it a lot worse.
Okay. Yeah, we can definitely tune it so that it's approximately the same.
Cool. Thank you.
Yeah, I
have a comment on mobile too, but maybe Pavel's about to say the same thing.
So it's not the same, but I started fixing inderness in CPP implementation, and also I wanted to optimize DAC loading. So in the end, it ended up to be a separate project, and it has endians correct, and also like for Peter's information, the cache generation, the small cache generation takes around half a second. I haven't benchmarked on mobiles, but if that's something like it's something performance critical, we can compare numbers and
Half a second on a mobile phone?
no, it's not on mobile.
Well, yeah, that's so basically generating the cache on Go Ethereum it's really fast, but on mobile phone it takes 3 minutes.
Okay, yeah. I mean, I can start like benchmarking that on mobile as well, if that's something that is critical on mobile devices. Yeah, just wanted to inform that there's like the site implementation of eFhash, if that helps. And we want to actually use it in, I think, in Ethereum JS to switch from the old library.
Okay, Alex, did you have something?
Yeah, I did. I apologize that I couldn't actually find my notes on this, but I do really I like the proof of work proposal, although I really am not sure if it carries the same properties due to the F&V function. So its validity is outside of my expertise. However, I noticed when we initially adopted it, and I'm curious if this was noticed by Miss If, Mr. Else, and Mr. Diff. Anyways, so you might look into. I believe that the light client DAG generation is actually somewhat redundant, in that basically the property of this protocol is maxing out the sort of the, like you said, the DRAM on the GPU, and I recognize that. And when we were looking at like the hardware performance, because we noticed there was also like difference between NVIDIA and AMD and stuff like that. So the point is that I think that the fewer cycles are required for the light client DAG, and the effect is the same. So in other words, like the protocol, I think, can be tuned to where the light client has like 128 less SHA-3 cycles or something like that per one of the cycles. I can't remember, but I would encourage looking into that, because that might actually, if you reduce that, that might compensate for the addition of the math operations. So I wanted to point that out, and then also ask if the protocol has the same security properties as far as it being acyclic and quickly verifiable on the light client. I think that's assumed, but I'm curious if there's any information on research on how the random mathematic operations for each DAG or whatever, if that reduces the security properties of the graph.
So the basic structure is the same as Ethereum, the existing ETH hash, and there's an array of basically register file elements that are calculated. One of them acts exactly like the existing ETH hash implementation, that it loads a random value from the DAG, updates its value, and then goes on to load the next value. There just happens to be a bunch more happening in parallel. So even if you somehow have a security weakness due to the random math that's happening in parallel, the main load is going to give you the same security guarantees as you have with today's Ethash.
Got it. And did you by chance run into the a quick note, by the way, on the redundant DAG generation cycles? What actually happened at the time is that everything was ready to go, and we'd already launched Olympic, and we were kind of ready to launch the mainnet. So it like nobody wanted to go and refactor that out. So I would be curious if you post on GitHub somewhere. If you look into that, it would be great if that small bit of redundancy was optimized. Even if it's not adopted by Ethereum or something, I think it's a really useful protocol for general use cases.
Yeah, I haven't looked into the back history on that, but we can definitely look into how the light client implementation is done.
Cool. Are there other comments or questions?
Yeah, I had a comment. Another aspect about these proof of work proposals that I don't see often mentioned is verifying them in contracts. So with Ethash, we have some efficient ways to verify Ethash block headers in contracts, and that enables cross-chain atomic transactions or cross-chain relays or bridges or however you call them. And whereas in contrast to like Dogecoin, Litecoin's S-script hash function, there's no efficient way to do that in a contract, so it requires really fancy things like TrueBit in order to do an Ether to Dogecoin relay. And so if a different proof of work algorithm was adopted on the main net, well, for one, it would break all existing contracts that do relays, and so I guess I would suggest a Solidity implementation as well of verifying headers that would use this alternative proof of work algorithm. And that's it.
Cool. So any other feedback or comments, especially based on Casey's comment?
We were not aware that proof of work would break the relay contracts, so definitely we can work on a Solidity implementation to fix this.
If you're looking at an example of an Ethereum-based chain to Ethereum-based chain relay, look up Loilu's Peace Relay. It's Ethereum Classic to Ethereum, and I don't even think it's in use right now. I think it was a proof of concept, but that's an example of verifying Ethereum-style headers in a different Ethereum blockchain, if I recall correctly. And then another one would be the Doge Ether Relay that uses TrueBit. I'm not sure if that actually uses headers or not. I haven't looked at it closely enough, but I can send you the link to that, and that might help you some.
Sure. So we'll definitely take a look at that. I just wanted to address that the key message for why we're pushing this and why we are so motivated for this is that while Casper FFG will provide finality and security during the hybrid period, there are still proof of work vulnerabilities, specifically censorship attacks, where that can be accomplished by ASICs, which we've already identified are running, and this can all be mitigated by proof of work. So later today, we will have more of a complete statement on this attack, a detailed, basically explanation of the attack, and this is our main motivation for proof of work. We want to ensure that proof of stake has its best chance for adoption by giving it this transition period, giving the transition period a fighting chance.
Okay, great explanation. Thank you. Anybody else have comments?
I just want to comment that in a general sense, the attack is a proof of work general weakness that relates to what happens when the block rewards are reduced, and you basically reduce the security of proof of work. It's not specific to ASICs. Anyone who owns basically more hash rate would be able to perform the same attack.
Okay, sounds good. That separates it. That separates it from some of the ongoing discussion about ASIC resistance for sure. Danny, did you have a comment?
Oh, I was, and I mean, I think as you all know, that attack ends up being a lot more limited by the finality. I know you might be maybe detailing something later today that has to do with censoring the vote transactions. But I will say, I am kind of from this is not the entire Casper team. I'm not sure what everyone's opinions are, but I do think that, if there is a easy switch to make this thing potentially more ASIC resistant, if that's this new algorithm or just tuning the ETH hash parameters for the time being, I'm generally in favor of it, because I think that it does give us just more runway to make the switch in a more conservative fashion. But it's my 2 cents.
Cool. Thanks, Danny. Anybody else?
Yeah, we hear that. We are definitely, as Ms. If said, working on trying to make this as painless as possible. And furthermore, we agree that it doesn't change the finality behavior, and finality is a good thing. And this is totally independent of there's no weaknesses to the proof of stake side of Casper, of course. We all look forward to seeing that be adopted as quickly as possible. We just should be a little bit careful about what happens to reward reductions to the security of this proof of work part. And in terms of the proof of work part, as a general attack, censoring means also that you can hold the network hostage with a 51%, where you don't allow any other transactions through. Except the attacker's blocks.
Okay. Thank you for that. Anybody else have anything? Okay. If def else, or def else if, or whatever order I'm supposed to say it in, thank you all so much for stopping by and explaining ProgPow. It sounds like a really technically interesting project there. So the next agenda topic is going to be, let me see here, EIP 210 block hash refactoring. Martin put a note up. It says, see the summary document in the agenda if you refresh the page on item 6, and that kind of gives an overview of it, but Martin can also go through and explain it again a little bit. So Martin, go right ahead. Martin, we can't hear you. Can you hear us? You're unmuted on Zoom. Are you muted on your local microphone? Oh, he hears us. Okay, he's fixing it. So yeah, while that's happening, if y'all want to open the summary document, that would be nice, because it gives a really good overview. I looked it over right before this happened. Okay, we can move on to EIP 1051, number 7, and then go back to 6 afterwards once Martin gets his stuff fixed. Nick, are you on still?
Yes, I am.
Wonderful. I think this is your topic, right?
Yes. So this is fairly straightforward in principle, and it's been raised before. There are some technical details to work out, and some interesting points been raised on the Magicians forum about whether this should be a trap, like a flag and trap type operation, or a flag that's cleared, or what the best implementation is. But the reason I wanted to add it to the agenda was to get a general gist for what client implementers think of overflow checking in general. My view is that the vast majority of math operations want to be overflow protected. There are definitely use cases for overflow in math in the EVM, but most people are working with the assumption that there won't be overflows, and thus presently have to code around that explicitly at significant additional runtime cost. So I think it would be useful to add a backwards compatible way to support overflow checking in the EVM that lowers the costs to clients and makes it more practical and more secure to do so. So I'm curious what the client teams think of this.
I can't speak for everyone on the team, but personally, I believe that this is a good change and something that will help developers, and prevent them from shooting themselves in the foot, which is always good.
So, Nick, would this negate the need for safe math, like stuff?
Assuming that Solidity implemented support for the new operations, then yes, it would.
Okay.
I mean, to be clear, Solidity could implement support for overflow protected math right now, but it would be doing effectively the same thing that safe math does. So it would still be a significant performance impact.
Right, and Viper does have it, and if we had native opcodes, I'm sure they'd move to the more efficient implementation.
Anybody else have comments?
Am I reading this correct, Nick, that basically for like Solidity or Viper to take advantage of this, it's going to add like some level of constant overhead to each use of the like add, subtract, or multiply opcodes?
It depends on how your implementation is doing 256-bit math at the moment. Some implementations will be able to detect overflow trivially because it's already available to them and they're just throwing it away. Others will have to do extra work.
I guess maybe even a more specific question is basically that in order to do a check on an operation, the at least like previous check has to have happened to make sure that the flag has been reset. Am I reading that correctly?
Yeah, so you would have to, each arithmetic op, you would have to OR the flags register with the flags for that operation.
And another kind of naive question, would we be able to get rid of that overhead by changing the add, subtract, and multiply opcodes to reset the flag on entrance?
So personally, so if you use a trap mechanism, then you can simply, if you have an overflow, you jump to a trap address and you don't need the flag. But if you're using a flags mechanism, then resetting the flag on entrance it wouldn't be any more efficient. And it seems to me that it would kind of void some of the purpose of having a flag, because the idea is that you can do a whole basic block worth of operations and then afterwards check whether any overflows occurred, which means you only need one check per block.
That is the piece I was missing. Thank you.
Paul, did you have a question or comment?
Yeah, so from the implementation of arbitrary precision integers, I mean, I think it's quite easy, but it's small penalty to detecting unassigned overflows. But I'm unsure about the signed overflows actually, and how would you like to distinguish them in EVM, where it's not so obvious which operation is meant to be for signed addition, or which one was meant to be for unsigned one?
So the idea is that the EVM instructions set the signed overflow flag if there was an overflow, assuming the values are signed, and then the code that's running in the EVM chooses whether it cares about that flag or not.
Yeah, but does it mean you would like to have two flags for signed overflow and for unsigned overflow?
Yes.
So I'm not sure that actually if you do like regular arbitrary precision implementation, you mostly do it using unsigned numbers, and then you try to incorporate sign later on. So I'm not so sure it's so easy to actually get the signed overflow information doing it this way. Maybe there's like the way to actually transform the result after it. But yeah, it's not obvious to me at this moment how to do it.
If your number is represented in 2's complement, then there are very simple rules for checking the sign bit of the input operands and the output to determine whether an overflow occurred.
Okay, thank you.
Just wondering, with EWASM, I know it counts for metering. I think the changes proposal is great, but I'm just wondering, because EWASM has built-in metering, right? So does that kind of negate the need for having these kind of changes to gas costs for optimization, or would these kind of changes still be helpful if we had EWASM in production?
I think for EWASM, you'd have to ask the EWASM team if I wouldn't add instructions to EWASM specifically for overflow if it doesn't already have it. And if it already has it, then we could use those.
Right. Yeah, I mean, I was thinking more in general, like generality, not just like overflow checking, but yeah, more just general changes to gas costs if they would be necessary if we have EWASM that can do metering to determine the gas costs based on the metering. Yeah.
Okay. Anybody else have comments on this? Okay. So yeah.
I guess I'm curious just for is Peter here? Is anyone from the Geth team here? Martin?
Peter's
I'm just
here.
curious. Okay, I'm just curious what you think of implementing it in Geth given the current 256-bit math operations.
As in how complicated it would be, or
do you think it will impose a significant additional burden?
I would have to investigate that and get back to you.
Okay, cool.
So I know that there are some slight challenges, for example, with division. I know that, or exponentiation. I think, yeah, exponentiation. It has some. It's based on some special algorithm that kind of assumes that you can randomly cut off anything above 256. So yeah, I can't answer this question now.
Hey, Greg, what'd you type in?
Over in chat. Over in chat, I just sketched out the change to the C++ multiply operator. I repeated a line at the start of the second part, but basically I would have to cast one of the operands up to 512 so I could get a 512-bit product. Then I have to check whether the product is bigger than the overflow value and trap. If I'm not going to trap, then I have to cast the product back down to 256 bits. So it seems a significant amount of extra work, and that extra code will have to be added to every arithmetic operation.
It would also like double or triple the cost relatively to the others.
So the arbitrary precision math library you're using has 256-bit limbs and no support for overflow then?
Yeah, you can't get at any overflow flag.
But it doesn't have, I mean, how big are the limbs?
How big are the what?
The individual words in the arbitrary precision math
They can
library.
be as big as you want. So that's why I can use a 512-bit word to overflow into and then
Can't you
check
just,
whether it got too big.
why does it need to be 512 bits though? Most big num libraries have smaller limbs than that, and they would just add one extra limb for an overflow.
This is a multiplication, so it can flow bigger than that.
Oh, sorry, this is just for multiplication then.
Yeah, addition you only need a little bit more, but
Okay. How are you currently multiplying with a 256-bit output?
I'd have to look inside. I believe the library just sort of automatically masks off the overflow.
Okay, so the library masks it out, but it has no way to, you have no way to get at that short of modifying the library, is that right?
Well, I just tell the library to use a wider word.
Then isn't it already doing that multiplication work?
Yeah.
Okay.
Okay, so it sounds like there might need to be a little more investigation into the cost of this between the clients.
We have a lot of clients using a lot of different libraries, and the libraries vary in what they expose.
Mm-hmm. Yeah, so what's the best way to accomplish this, I wonder?
Testing.
Yeah. Is there any other?
Yeah, would you just find out from me, Wasm, if with metering, if that would help, if that would render these kind of changes like not necessary. It sounds like it could be complicated for different clients, but yeah, I'm just speculating.
I'm not sure I follow where metering comes into it. I mean, this kind of change is irrelevant to eBOSM anyway, because we'll be using their opcodes, not ours. So I'm not sure. Can you elaborate on why metering is relevant?
So as I understand it, metering you can use to meter how much computation is done. So it's computation, not storage. Like the memory loads and stores and M loads. But yeah, my understanding isn't great of eWasm, but I have read the spec, and I just thought that perhaps with metering you would not you'd be able to measure how much computation is done, so that you can then see you don't need to play around with the gas costs in EVM so much.
Sorry, are you thinking about the
optimization?
I think you're thinking about the later in the agenda about changing gas costs for S-Store. We're talking about for supporting overflows.
Okay. Yeah, I understand that. Yeah.
So, Peter, did you have a comment, or Piper?
Yeah, I did. Maybe this is a naive thing on my part. I was under the impression that multiplication overflow checking can just be done with division rather than having to deal with much higher scale numbers. That essentially doing an inverse check that
Big number division is very expensive too, however.
All right, fair point. Either way, this seems like a positive thing, and while we might have some concerns about the overhead it adds to some commonly used opcodes, seems like something that might be worth implementing, especially since languages are kind of already pushing the stuff in the first place and adding overhead to their contract code. I don't know. I haven't thought about this a lot, so that's kind of just a gut reaction.
So like Greg mentioned, testing is probably the best way to do this. Can that be accomplished for some of the main clients? Is anyone interested in doing that?
I think maybe the best initial step would be to ask for somebody from each client in the next all core devs to say whether to have a quick look and say whether they think it's necessary, whether they think it will be an undue burden to implement in terms of efficiency or developer time. Because as Greg pointed out here, there's a lot of different implementations out there for the big num math.
Okay.
I started working on custom implementation of arbitrary precision for C++. I know also that Martin had similar idea for Go. So I can take a look there and see how intrusive it would be to actually extract this information out of it.
Okay. Okay, that sounds good. So we have a next step that we're going to be doing with that. Is that good, Nick? We'll go on to the next agenda.
Sounds good.
Cool. Let's go back to 6, block hash refactoring. Martin, is your mic fixed? Oh, or did he leave again? Yeah, he's not on here anymore. Okay, we'll table 6 until Martin either gets back or until another time. The next one is EIP 1052 Xcode hash opcode. That is Nick.
Yes, so this one's hopefully fairly straightforward. There's an increasing number of use cases where on-chain a contract wants to know what the code of another, whether the code of another contract matches a known template. In order to do various things such as trusting only certain implementations and so on. Presently, they have to fetch the entire code into memory and then hash it and then throw it away, which is a waste of gas, and we already have this information in the EVM. So I'm just proposing a very simple opcode that pushes the data hash of another contract to the stack.
On the surface, this seems good. It seems like this would encourage languages like Solidity that include an extra, like I think they include a swarm hash of some information in the contract bytecode, which would sort of, well, I guess it already makes this problematic if you're checking against the full code. Seems like it would discourage that practice even more. But in general, it seems positive.
I would agree with that. It would be great if somebody could do some asking around as to why this wasn't in there to begin with. But it would be really great to have this. It uses a ton of gas, and it seems like a really useful operator for, well, for some of the projects that I've seen people working on recently.
For why it wasn't included originally, I think it was just an oversight, although I don't have any insight into whether that's the case or not.
Yeah, from the VM perspective, it's also very useful information, and it's some of the implementations I care about. It's used to actually have unique identifier for executed code. So, for example, in EVMC, this information is already available to VMs, so it wouldn't be very problematic to expose that to contracts as well.
Yeah, and it's also like really fresh. It's already loaded in storage if you've already hit the code. So there's it's almost no cost to actually implement that, and probably only a couple lines of code in most of the clients.
That was my guess as well. I think we should probably price it the same as the base cost of Xcode copy, because if you haven't touched that contract, it will require loading it, but that would still be a big improvement over the current solution for getting the hash.
Yeah, I'm not sure it would be this. Is Xcode copy based purely on the byte size returned, or is there an initial gas cost on that?
I believe it has a base cost and an additional cost per byte, but I'm just looking it up right now.
Yeah, it should be like the same cost as like checking the the balance,
Yeah, it
or
should be,
slightly less.
it should match the Xcode size, which is actually
Yep.
it's
So it is.
700. Yeah, 700
It is
plus
the
3
cost.
times the number of words.
Exactly, cost of an
Yeah,
Xcode
exactly.
and cost of a gas copy. So I think we should just make it 700 gas would be the simplest.
Or Xcode size, like Pavel said.
Which is 700.
Right, which is so in the white paper, Xcode copy is described as the cost of an Xcode plus the cost of a copy times the number of words, and sorry, what was the other one? Xcode is the cost of an Xcode. So
Okay. What do you think are next steps on this one, Nick?
I think it's reasonably well specified right now and reasonably straightforward. So really just to see whether clients are happy to implement it and whether we can move to accept it.
And this would be something that could be implemented without a hard fork because it's at the VM level, right?
No, it would have to be a hard fork because it
Oh.
introduces a new opcode. So it
you're
would
right.
be added to the next hard fork.
Okay.
It would be good to do together with the
Bitwise shifting?
with EIP 210. I don't know. Maybe I don't know what the status of things are, but if 210 goes through, because that also adds that adds an opcode.
Yeah, well, actually, Martin's back now,
actually,
so he can
yes,
talk
can
about
you hear me
210.
now?
Yep, we can hear you.
Nice. Yeah. So actually, EIP 210 does not add an opcode. However, so I don't know if you guys have.
Sorry, it sort of changes the
right
calls in the EVM. Yeah, virtually changes it.
Have the HackMD note up. So a couple of problems with how it's written right now. I divided it into two. So the intent, and it would have been good if Vitalik was on the call, so I don't know if we can solve this now or maybe we'll have to talk about it next time. The intent was to not change the semantics of the opcode block hash. So the opcode block hash would still return only the last 256 hashes. That's what he wanted. However, as it is specified and as it is written in the contract doesn't care if you ask about only the most recent or if you ask about older stuff. So as it's written, it will be the same thing. Basically, if I do block hash on a very old block or if I actually call the contract way back. So one alternative is to do it as Vitalik wanted it from the beginning, to modify it to make it clear that when you call it, when you do the block hash opcode, you only get the latest 256. And in that version, it doesn't change anything on the block hash opcode semantics. So the clients would actually not need to do any changes for that opcode. The only thing that would be required would be to increase the gas cost for it. However, that would mean that in order to get more useful information, people would have to call it. And it would maybe be nice to add for an ABI encoding or decoding to it so that you could just, call it nicely. The second alternative is to have the EAP as written. That would change the block hash semantics because you could reach further back. I don't know. That makes it kind of, why would you ever call it if the block hash exists like that? And then the second issue, it's not really an issue, it's a question. Should we add support to obtain the Genesis hash from this contract?
Absolutely.
It would be a nice thing. It complicates a little bit because we need to shove it in there during contract creation, but it's probably a nice thing to have in the future.
Paul, you added another point D on this, that there's an EIP
Yeah, so
to fix
there's
it.
one bug with it is that if you invoke it at block 1, sorry, if you do right, then you go into an endless loop. And that's basically the problem. So that affects mainly test cases that execute it.
I see. Okay.
And Pavel, what was the other issue about signed integers? I didn't really catch that.
Yeah, so the current contract is implemented in Serpent, and Serpent only has signed integers. I believe it's hard to. I mean, I had to guess that, but it looks like from the behavior I get from writing unit tests. So there was some comparison inside the code that actually accounted for it, and so you can overflow this comparison and you get some unspecified results. I mean, they are specified, but it's not what you wanted intentionally. So there's another check needed in Serpent because to check if the argument from the call it's not negative. So there's a pull request that fixes these two issues. I plan to continue working on writing unit tests. It's not clear. It's the unit test should go to the EIP's repository or it has to be on the site somewhere. But I think it's minor issue to figure out. And okay, so I wanted to actually add more unit tests to make sure it works as specified, and then I would think about like optimizing the contract with something using maybe Solidity assembly or something like that. It's not mandatory to do that, but having unit tests, it's quite easy to test if the results are the same and the costs are lower. And so that's one thing. And commenting on Martin's propositions, I would go with the first alternative version when we don't modify block hash opcode. That's one thing. I mean, I don't want to give a lot of arguments for it. It seems just safer. And second thing is about the Genesis block hash. So actually, this bug with at block 1 means you wanted to insert the hash of the Genesis actually, and I believe there is a generic solution for it, which I would try quickly explain, but it's not so easy to do on the call. And so mostly instead of replacing some stored value, you can actually move them to different storage location. In this way you will keep all the information all the time about some specific blocks, so you never overwrite some important information. And the block number 0, it's like meets all these requirements, being division by some multiplication of 256. So in case so I believe you can change a bit the logic of how you store information in this way. So if you would run this contract from the block 0, from the block 1, you will have this information about block 0 all the time. So
right.
This is
we want to do that.
This is like abstract solution for that. And the second part of the solution would be to actually also insert the missing information and the deploy time, so we can actually have all this required information also on the mainnet. So that would somehow solve the Genesis hash problem, but I think it's quite complex comparing what we have right now in the contract. I mean, I haven't finished the the prototype of the implementation. It seems it requires recursive functions or something like that. Maybe it can be flattened down later on. I'm not really good at algorithms, so I cannot do it very quickly. But that would be one of the solutions to this block hash, and also it might be a bit problematic to actually insert all these block hashes on the time of the hard fork. But another good property of that solution is in the smart contracts you can assume the information about historic blocks are already there according to the specification. You don't have to account also the hard fork number to in your contracts to actually compensate this lack of information, because this change was introduced in the middle of the mainnet, not in the beginning.
Okay, let's summarize that into parts of the EIP discussion. And I think that the PR that you opened, I think it was 1057. No, wait, what was it? 1094 is appropriate to include fixes for EIP 210. But we might also take those comments to EIP 210 itself so that it's kind of kept up with by everybody, or at least linked to the PR. Great. So does that kind of cover most of your EIP 210 stuff, Martin?
Yeah, I'm fine with going with the original intent. I would like a nicer ABI, and I would also like the Genesis lookup, and I think it could be done pretty easily if we don't go with some more generic approach and add a lot of milestone block hashes on the way, but just the Genesis.
Okay, sounds good. It looks like we're pretty much out of time, so Nick and Greg, I'm gonna have to move your items to the next core dev meeting. The EIP 1087 and the concern for using native browser VMs while running eWASM. So I will move those to the next meeting. Sorry we couldn't get to them today. And otherwise, we'll see everybody in 2 weeks. I'll also if you all go to the Ethereum/PM repo, I wrote up what the core dev meetings are about, the purpose, who can join, how to add agenda items, stuff like that. And then I'm also going to elaborate further in either a blog post or a Reddit post or something about some of the changes that are going to be happening to the core dev meetings, particularly specifying how they're going to be more technical in nature and have less philosophical discussion and things like that to kind of help save time and not have it be the core devs deciding everything in the ecosystem, because that's not really what we're after here. It's more to figure out core development, low-level protocol issues rather than high-level issues and contentious community debate. So yeah, we'll talk about that more next time. Thanks everybody for showing up, and we'll see you in 2 weeks. Goodbye.
Goodbye.
Thanks everyone.
Bye.
Thanks,
Bye-bye.
everyone. Bye.
Thank you very much. Bye bye.